So evaluating logarithms is the exact same idea that we were solving earlier with powers. We're going to use our powers chart. Probably the first thing you're going to do is change this to exponential form. And one way that you can do that is introduce a variable, say let x equal this, then the base is 5, the exponent is x, and the answer is 3,125. Now, if you can write 3,125 is a power of 5, it happens to be 5 to the 4. I don't think we went that far on our powers chart. So if you didn't go that far on your powers chart, here you would be taking out your calculator and guessing. Say, well, I know that 5 cubed is 125 because that's on my powers chart. Maybe I'll try 5 to the 4. If it wasn't big enough, try 5 to the 5. And then from here, once the bases are the same, by observation, we can go, so x has to equal 4. And that is evaluating this logarithm. We now know that this logarithm equals 4. Okay? If you introduce a variable, you have to define it. So there's no x in this question. So if I want to change it to exponential form and put an x, I have to say let x equal this to start with, so we know where that x is from. And then I can say my base is 6, my exponent is x. 216 is on our powers chart. It was 6 cubed. But that 6 cubed is in the bottom of my fraction. Sam, is that yours? This? Yeah. Yeah. Awesome. What'd you get? Was it 1 out of 10 on the top end? 10 out of 10? Oh, shoot, I forgot to put it. Oh, yeah, I'll put it. And then this point, now you can go, so x has to equal -3. Now, in these examples, do you notice that we're doing them the same way we did our examples earlier? I find on the pretest, if you know how sometimes you don't know how to do a question, you click check the understanding button. I find that they do these ones in a little different way, and I think it makes it harder. It's kind of nice to do it the same as we were doing before. So just, if you get stuck on these, I'd recommend looking back at your notes. You can see how they did it on the pre-quiz when we get there, but I think this method is easy. Okay, so last one here, I'm going to let x equal, and then you would have 8 as the base, x as the exponent. And in order to solve this, can we get everything to the same base? Yes, 8 is a power of 2. 2 cubed. Cube root of 2 I can change to 2 to the 1/3. Then it's just using your exponent laws. Power to a power, multiply. 2 powers with the same base, add the exponents. 1 plus 1/3 is 4/3. So by observation, 3x has to equal 4/3. Divide both sides. By 3, and you would get 4 nuts. And these ones I'd like you to try. So take a little bit of time, go to questions 4, 7, and 9.